Hi guys, welcome to this new video on Python. So in this video we are going to learn about how to verify hypothesis testing of population mean with a small sample. So in the last video also we saw the same, but in that case we had parameters about the population. So here but we only have some statistics about the sample. So let's read the question first. A factory that produces dumbbells, the average weight of dumbbells produced is specified to be 25 kg. So we are given that mu is equal to 25 kg. Then during the inspection, the plate manufacture process, we want to check whether the factory is producing plates of specified weights. To test this, a 20 random sample of 20 dumbbells is selected. Verify the claim with 5% level of significance. So besides that, we are given that the alpha value is equal to 0.05, and then we have the sample where the dumbbells weight is given to us. So in this case, first of all, we need to find out the mean of the sample, that is x bar. Then we need to find out the standard deviation of the sample, and we can state the hypothesis as H0 and HA, that is alternate hypothesis. So we need to check whether the factory is producing plates of the specified weights. So that means that we need to verify that whether the mu is not equal to 25 kg. So obviously in the null hypothesis it will be equal to 25 kg. So since we have this inequality symbol here, so it is a two-tailed test. So many people often get confused in this case that whether to use Z distribution or whether to go for T distribution here. So you should note that you should always go for Z distribution if you have parameters about the population. But in this case, we have n, that is number of sample, that is equal to 20 first of all, which is obviously less than 30. Along with that, we are only given details about the sample. We are not given details about the sigma, that is the population standard deviation, is not with us. So we'll go for the t test here. So if we plot the t distribution, we need to find out t critical at 0.0250 along with the degrees of freedom here. Since it's a t test, so the degree of freedom DDOF will be how much? It would be, we have 20 samples, so it is 20 minus 1, that is 19. So this is 19, and T critical on the upper side will be 0.9750 and 19. Let's solve this problem with the help of Python now, and let's verify the claim. So we are importing some basic dependencies, that is scipy.stats as sp, then we have the statsmodel.api as sm, and we have numpy for basic computation. So let's import them. Now I have captured the data of the sample that we collected for the dumbbells in a list here, that is this data variable, and firstly we are calculating the mean, so that is x bar for the sample. So let's print out the sample mean and the sample standard deviation, that is S here. So we get that the sample mean is around 25.51 and the sample standard deviation is around 2.1377. Now we go for the t-test directly here, but before that we need to plot the critical values. So here we have alpha, that is equal to 0.05. The number of sample size was obviously 10, and then we go for the lower limit and the upper limit, and since it's a t-tailed test, so we use the ppf function of t distribution here, and we pass alpha by 2 and 1 minus alpha by 2 along with the degrees of freedom here. So let's see what are the degrees of freedom. So we get that the critical range is minus 2.09 and plus 2.09. And since the alternate hypothesis is on the other side, so we can say that this part is the critical region. So from the scipy.stats we import the t-test one sample first of all, and then we pass some parameters to it. First of all, we pass the whole data sample that we have. Then we pass the null hypothesis, which in this case will be 25. Then the axis is equal to 0. NaN policy propagate, and it will automatically infer, since the axis since the null hypothesis here is 25, so it will automatically find out the alternate hypothesis and we'll get the test statistics and the p-value. So let's print it. So here we get that the test statistics is equal to 1.039. So if we just plot this 1.039, so it will be somewhere around here, 1.039. So this is the value that we got, and it falls in the non-critical region. So we cannot reject the null hypothesis. So we can say that the null hypothesis here is true and the alternate hypothesis here is false. To verify our claim, we will also check for the p-value test here. So we get that the p-value here is 0.3114. So if we write the p-val is equal to 0.314, which is obviously it is greater than the alpha value, that is 0.05. So we can directly say that the null hypothesis here cannot be rejected and it is accepted, and the alternate hypothesis here is rejected. That means that we can say that the random sample that we took specifies that the average weight of the dumbbells produced is equal to 25 kg with 95% of confidence interval. So this was all about that I wanted to show you in this video. Feel free to ask any doubts if you have in this video in the comment section below. We'll definitely do some brainstorming on it. Till then, if you like my work, please do hit the like, share and subscribe button.